So browsing the tree space using a branch swapping the purpose is to jump over a div-valley. And then again, we already mentioned about it's possible you are trapped in a local mountain peak, and that is called a tree island. There's a specific term for that. So it's best to have a random starting point to avoid being trapped on the tree island. And this is also an option for like pop star. And the pop is one of the most commonly used program for measurement parsimony. And if you can choose, there's an option called the random starting point, and how many random starting point you are going to ask the computer to do that. It's for me, I would recommend that you choose 1,000 or more random starting point. The more, the merrier. But each starting point, it will take a lot of time to calculate. So it really depends on how much time you have for calculation. And there's a new way has been developed for finding the best tree using parsimony criteria. It's called parsimony racket. And basically this idea is to reweight the subset of the characters and to try to give a random weighting for a certain character and to search for the most parsimonious tree at the end. And basically this is again try to randomize and some of the effect for some character might dominate the result and give you a bias and trap you in a certain tree island. Basically that's to avoid that. So the whole process is like this one. Before that, this is just an example for the tree island. It could be possibly found. And this is the result from the 1 million trees and you can see there are 4. Okay, these are the islands list here, and these are the tree lengths I just grouped here. And for a lot of trees we found and are actually formed into 33 different tree islands, and each tree island has different tree lengths. And some of the tree islands are better, some of them are not. So this is very important to have a random starting point. I think I need to have this slides a little bit further before. Let's go back to the parsimony racket. And it was developed by Kevin Nixon from Cornell University. And he also incorporated into his program of Nona Wincrada and somebody else Pop-Rate. And the process is like here. So first of all, you just need to start a random Wagner tree, which is a non-weighting tree, and random select a subset of characters. Okay. So for example, you have a lot of characters. You just randomly choose some of them, like 20% or 5% of them, and give a weighting score for them, which means that you will have much more emphasis on certain character than others. And afterwards, you will perform a TBR branch swapping to keep only one tree and reset the weighting to original, and perform the branch swapping to keep the best trees and return to step 2, and keep doing that and repeat this process, and it'll give you the estimate for the best trees you got. And here are the actual result from one of the data set. I think it's from the 500 sequences from angiosperm, I think. And here are the replicates, the repeat process, the number of the repeat process for this is the tree length. So here I'm just showing without using this non-racket method. So during different replication, for example, this TBR branch and random starting point, and keep 5 trees per replicate, And this is the process for having a tree length, the number of the tree lengths right here and right there. And you will find something like this one. This is one of the tree island. There's the tree length 16538. And then after 500 replicates, you'll find another tree island. It has the number of 16537. It's one step shorter than this tree. And then after 800 replicates, you'll find another one, which is one more step shorter. So random starting point is nice. You can give you some of the shorter and another tree island of the tree. And the lower diagram is showing using his method, Rekit, and 40 characters reweighted. And you're seeing this the process of replication. And this is the number right here, 16538. About 5 replicates, you can get the result. And after 60 replicates, you can get 16531. It's even lower than the number you can get from the random starting point. So Kevin Nixon claimed this is the much better method compared to the original method. So likely. And so theoretically, it seems to improve the effectivity for the tree searching. So I recommend to use that if you are comfortable with this method. But the problem is that we don't know much detail about why is this will affect the tree searching outcomes. And anyway, so this is one of the methods you can choose for.